Okay, hello everyone. Our team is named QuadriPower, and we've been working together the past few days to tackle the Chevron problem statement. And we're excited to share with you our emissions reduction strategy proposal for the Lost Hills oil fields. So the first part of the challenge statement required us to determine the greatest contributors to the scope 1 and 2 emissions before the solar farm was installed. So through analysis using figures from the provided materials, we determined that oil and gas production, along with the power source from the grid for operations, were the largest contributors to emissions. You can see the formulas in the footnotes below to see how we determined metric tons of CO2 emitted per year. We then used a couple of assumptions to determine the impact of the solar installation at Lost Hills. The solar installation is used to power the operations at the field, so it will only be cutting emissions from scope 2. And first, we assumed that the 80% power generation was coming from both solar and batteries, and we also assumed a linear relation between the two. So with only the solar installed, 36% of the emissions from scope 2 would be reduced, and with both solar and battery combined, 41% would be reduced.
So for the second part, we took into account that Chevron is one of the largest fuel producers in the world. We decided to implement Power-to-Methane as our plan to reduce carbon emissions. Power-to-Methane consists of the conversion of electricity into methane by a two-step chemical reaction. First, we have the electrolysis of water into hydrogen and O2, which is an endothermic reaction, meaning that it requires an input of energy. The second step requires a source of CO2, which is then converted into methane. The advantages of this process are that it can be operated under normal temperature conditions like 25 degrees or between 30 and 60 degrees for the second step, and that there is no net water consumption if you check from the first and second reactions.
By choosing power-to-methane, we can use the excess energy produced and in the same time depreciate CO2 emissions. We decrease scope 1 emissions by capturing a portion of the CO2 emitted. We can also cut down scope 2 emission by using the excess energy to capture CO2.
So for the CO2 emissions, we got the typical composition of the carbon emissions from oil fields, and we were able to determine the amount of CO2 generated per year, which is 16,600 tons. Assuming that the Lost Hills oil field operate around the clock, we were able to determine the amount of CO2 generated per hour, 1,900 kilograms. Then we found the energy consumed per kilogram of CO2 per month, depending on whether the carbon emissions or the energy available were the limiting input into our system. Finally, we found that 6,600 tons of CO2 per year could be taken directly from the oil field. And since part of the excess energy is now being directly used on site, it is eligible for the LCFS credits, which accounted for an equivalent of 12,370 tons of CO2. Therefore, in total, we reduced the CO2 emissions by 18,370 tons, which is equal to an additional 34.2% reduction in CO2 emissions.
The final cost of the methane production is $1,010,000. If we take in consideration the income from the LCFS credits, that is $2,474,000. When we subtract the final cost from the income generated, we have a total revenue of $1,064,000. $1,464,000. Thanks to Power-to-Methane, we not only get to reduce CO2 emissions, but we also increase the profits of Chevron.
The timeline represents the infrastructure and the process of the proposed power-to-fuel system. It's divided into 3 stages: the current scheme, the power-to-fuel proposal, and the distribution. In addition to that, there are 4 colored bullets to represent the input, output, process, and intensive carbon process. The infrastructure for the proposed system will take an estimated 2 years to complete and for it to be operational. In stage 2, we have determined that the proposal will require the introduction of 3 plants and reactors for the carbon capture and compression, methanation of carbon dioxide, and purification of the gas. Throughout the process, we have particularly highlighted the reduction of carbon emissions.
All right, you guys are about 5 seconds ahead of schedule, but that is perfect. So we will go ahead and begin the Q&A with the judges starting now.
So I'm Barbara Berger. Great presentation. A couple of questions that I'll ask. One is, what is California going to use the gas for? What was your thought process on that? And then the second one was, were you surprised that the addition of storage didn't make more of an impact?
So for the first part, for the methane, what Chevron could use, where it could use it could be used in different things like public transportation or in the heating industry, for example, or for heavy duty transport. And hello?
Yeah.
Yeah. So, and for the second question, yeah, we were a little bit surprised, but then if you compare them, the storage of the batteries, I would say it's quite small compared to the energy produced. So it's like less than 10%. So I think it could be expected.
Thank you very much for the answers and great presentation too. Again, two-part question, real quick. One, the assumption of the LCSF credits remaining, I guess, at 200 level. I'm looking at your calculations. And how do you see the LCSF credits as a function of time? And how will it impact your project? And the second one is, what do you think are Chevron's competitive advantage, being able to execute a project like this compared to other entities?
So I can at least answer the first part. So the first part, we had a graph that I do not have in front of me right now, but it showed like how LCFS credits changed, and you could see that went from, I think, maybe like $120 maybe 2 years ago, and then it was stable like from January this year till now. It was stable around 200, like $195, $200. And for the second part, I think what you can say is that Chevron is already a pioneer in fuels, and like you are used to like producing fuels and trading fuels. So I think you have a great advantage in this, like in the fuel production, and even probably you have already the equipment, and you have much better experience in this field, I would say, compared to other competitors.
And I would like to add that the costs of Power-to-Methane is expected to decrease in the next decade. So it's going, the total revenue is going to go up even if the LCFS credits are not $200.
Thank you. Jane, do you have any questions, or you're an insider too?
Yeah.
Can I ask one more question on the methane, on the Power-to-Methane? What is the state of commercialization? What's the amount, how many units have been constructed and are operating around the world, or are they still working towards that first plant?
So I can answer for the case of Europe. I'm not sure for the US, but I know that already some pilot projects exist. For example, Audi has a pilot project from where they take energy from wind farms, and I also know that it has been like it is going to be, or it can be like, it is going to be implemented with waste to energy power plants. Mm-hmm. So I think it is like increasing. Maybe it's still not mature enough, but probably in the next decade it would be mature.
Yeah, it's expected to increase by 10% till 2024.
Time, start wrapping up.
It's expected to go up to 10% to $42 million in 2024. But in the US, it's not increasing that much. And that's why I think it's a good idea to be one of the first companies to implement this technology.
Okay, thanks. Do I have time for one more question?
Unfortunately not. We have to let the other team in. But QuadriPower, thank you very much for your presentation and best of luck.